All right, this is the Foundations of Mathematics and Pre-Calculus 10 sample questions for algebra and number. And so in this section, there are, I believe, 16 questions. And they're questions that the Ministry of Education has put forward and said that, hey, students in Math 10, you might want to take a look at these. So just like when your teacher does that, it's probably a good idea to take a gander at them. So let's get started here. I'm going to try to go through the examples in a fairly quick fashion. I'll try to show you when there's more than one way to do it, but I might not be able to do that all the time. In any event, let's take a look at the first one. So the first one, you'll notice that it has this symbol right up here where it says no calculator. And of course, on the provincial exam, you'll find that there'll be the first couple of questions, first 12, I believe it is, where they will not have, you won't be able to use your calculator for those ones. Now, they don't make them so tough that you need a calculator, so they're definitely doable. So don't be too afraid of them, I guess I should say. So anyways, let's get cracking here. Which of the following powers is a perfect cube? Well, to look at them right now, you might not be able to see. One thing I want to remind you about is remember that if we break them down into its basic elements, and we see that you can put them into groups of 3. So if you take a look at this one right here, I'll show you an example. This would be the same thing as 3 times 3. Well, there's no way that you can put those into 3 equal groups, because remember, we're talking about perfect cube. Whereas though, I can already see on the second one here, 5 to the power of 6, you could go 5 times 5 times 5 times 5 times 5 times 5, and notice that you could put those into a group, these into a group, and these into a group. And therefore, since you've put them into 3 equal groups right there, we know that that's going to be a perfect cube. Whatever that number is right there, we actually know that when you take the cube root of it, it's going to be equal to 5 times 5, or in this case, 25. All right, so that'd be your solution for the first one. And so the next thing you're going to see on the provincial exam is there's going to be some questions that are going to take you a long time to do. You may spend upwards of 5 minutes on some questions, whereas ones like that and ones as you see in this next one may only take you a couple seconds. Okay, so this one says write as a single power 12 to the power of 3 all divided by 4 cubed. So they're kind of testing your power rules here. The thing that I would hope that you would recognize is that this can be rewritten if you wish. You can write this as 12 all over 4 all raised to the power of 3. And of course, now if you simplify this, we know that 12 raised to the power of, 12 divided by 4, I should say, is 3. And then 3 cubed would give you, in this case, 27. Since they don't ask you to write what the answer is, they just want it as a single power, we know that it would be like so. Okay. Let's mosey on down. We're banging through these. Number 3. So it says, given x is greater than 1, arrange from least to greatest these radicals right here. And so the easiest way to kind of compare these things, because that's essentially what they're asking you to do, is to write them in terms of a power. So my suggestion would be to do just that. And I think you guys know how to do it. Remember that whenever you have the square root of x, that's the same thing as you just having x raised to the power of 1/2. This one that we have right here, remember that when you have 1 over something, it's the same thing as having a negative exponent. So this is going to give you x to the power of 1/3, only because we have the 1 over it, it used to be negative like that. So recall that if we were going from this direction, if we were going upwards, you would kind of do the opposite thing right here. So that the 3 would end up going in front, and then the 1 would end up going right here. We don't need to write it like so. Okay. The next one right here is going to be x to the power. Remember, the 2 is going to go up top, and the 3 goes underneath. So now that we've written those in exponential form like this, we should be able to compare them. They wanted from least to greatest, so the least would have been this one. So we'll put this one would go first, x to the negative 1/3, and then we'd have x to the 1/2, and then x to the power of 2/3. Now keep in mind that they don't want you to express it in this exponential notation. They want you to write it in the radical notation part here. So therefore, we would say that the middle one right here was our smallest. This would be the smallest, 1 over the cube root of x. The next biggest, if you will, would be the square root of x. And the largest would be the cube root of x squared. And if we take a look at our list, I believe that is a like so. Okay, so first 3 in the books. Let's keep on rolling. Okay, so number 4 says 2 gears are shown below in their starting position. Gear 1 has 6 teeth, so this one has 1, 2, 3, 4, 5, 6. And Gear 2 has 8 teeth, 1, 2, 3, 4, 5, 6, 7, 8. As Gear 1 turns, it causes Gear 2 to turn at a different rate. So remember, this one right here we would say has 6 different teeth. And this one right here we would say, because these teeth, if you will, that teeth right there is fitting into this one, you could call this one and say that there are 8 openings, if you will. Okay, so we'll start with that. Now, what we're trying to do basically is we're trying to see when this will line up again, because remember the question says, what is the minimum number of rotations Gear 1 requires to return to its original starting position? So the starting position that we had right here, where this black one right there is in between those two like so. And so basically what they're asking you for here is they're asking you for an LCM question. We want to find what is the smallest number that both 6 and 8 both go into. And so to figure out the LCM, what I'm going to suggest that you do here is to do a quick factor tree. So if I start with the 6 on this side, it's not too shabby. It just gives you 2 and 3. So that would be the prime factorization of 6. We'd say 6 is equal to 2 times 3. And maybe over here I'll deal with 8. The prime factorization of 8 would be 2 times 4 and then 2 times 2. So we have this is equal to 2 times 2 times 2, which of course is 2 cubed, if you will. And remember, when you're trying to find the LCM, what you do is you take the highest power of each. So the LCM of this is going to be equal to the highest power of the 2's. So if you look, the highest power of the 2's, is it 2 or is it 2 cubed? Of course it's 2 cubed. And the highest power of the next term would just be 3. And so your solution right here would be 2 cubed times 3. So 2 cubed is 8, and 8 times 3 is 24. Okay. Now the tendency that students are going to want to do here is they're going to want to say that the answer is 24, and it actually isn't. This is a tough question, I would say. I'd say it's one of the higher level questions. Because remember it said, what is the minimum number of rotations? What we found out here is that's basically how many ticks it would have to go, if you will, for the gears to get all the way around. Well, if they're talking about Gear 1 right here, and it has to go 24 ticks, and they do 6 at a time, then that tells you that you just go 24 divided by 6. So it'd be 24 divided by 6, which would give you 4 rotations. Like so. So this is the number of rotations. All right, so let's go on to number 5. So I'd say that was kind of the toughest one that we've had so far, for sure. All right, here we go. 3 students were asked to show steps for simplifying the cube root of 1080 to 6, the cube root of 5. So they want to show that, that these are equal. Okay, so what we're trying to do here is we're trying to identify any issues that we see. All right, so let's take a look at what these students have done. So we have Jean, we have Sally, there should be a line right here, and we have Mark. So let's start with Jean first, okay, on the left. So it looks like Jean has broken this into the prime factorization, 2 times 2 times 2 times 3 times 3 times 3 times 5. Okay. Now, at this stage, what I'm going to do is I'm going to assume that that gives us 1080. Now, that could be a broad assumption, but normally the test maker on something like this isn't going to require that you guys know that. Okay. Now, if you recall what happens when you're taking the cube root of something, remember, if you have a group of 3, so we have a group of 3 of the 2's, then we take the cube root of it, the 2 essentially pops outside. So that looks okay. When you take the cube root of these, the 3 would pop outside. But remember, we don't add them out here. Instead, what we'd do is you would multiply them together. So it should be 2 times 3. So this answer right here, of course, is right. But this problem right here is the deal breaker. Okay. So which student made a mistake, if any? I would say it's Jean already. We know that that would be your answer. Now, let's just go through ever so quickly, if we can here. And take a look at why these other ones are correct. So we're going to say that this one was wrong right here, and these guys were good to go. So we have the cube root of 216 times 5. So we know that the cube root of 216, that's a cube root that I'd ask at least my students to memorize if at all possible. The cube root of 216 is 6, and then you have the 5 left over for 6, the cube root of 5. That looks reasonable. Mark over here is a different student. He's broken it down into being the cube root of 1080 is equal to the cube root of 27 times 5 times 8. And so this seems reasonable. He noticed that if you take the cube root of 27, you get 3, I agree. If you take the cube root of 8, you get 2. And the cube root of 5, of course, it is not a cube root. And then Mark simplified and went 3 times 2 is 6. So that would be your solution here. We found out that it was A. All right, number 6, dealing with our exponents here. So whenever you're doing an exponent question, there's lots of different ways that you can go about it. My suggestion always is to try, whenever you have an exponent like we do right here that's being applied to the whole thing, I like to simplify everything in the brackets first. So that's what I'm going to choose to do here. To do this, I have negative 54 divided by 2 gives you negative 27. All right, now dealing with our x's, x to the power of 6, all divided by x to the power of negative 3. Remember, when you have the bases are being divided, what do we do with the exponents? We subtract them. This is going to be 6, and this is, you got to be careful here. It's 6 minus negative 3, and 6 minus negative 3 would give us, of course, 9. Okay, now we're on to the y's. Again, the bases are being divided, so we're going to subtract the exponents. Remember, this is a 1 right here. So we have 1 minus 4 would give you y to the negative 3, like so. Okay, so I'm going to leave it like that. A little reminder right here is, remember, we never want to have negative exponents, but because I'm not done, I'm just going to leave that kicking it like so. All right, now from here what I'm going to do is I'm going to apply this 4 over 3, this power, to everything. So the 27 is going to get raised to the 4/3. The x to the 9 is going to get raised to the 4/3, and then the y to the negative 3 is going to get raised to the 4/3. So when I do that, I'm going to have negative 27 all raised to the 4/3. I'm going to have x to the 9th all raised to the 4/3, and I'm going to have y to the negative 3 all raised to the 4/3. Now, to do this, the easiest way I find, especially for the integer that you have here, is I'm going to write it in radical notation. So remember, what happens is the negative 27 is going to go under here, and the 3 comes out front, and the 4 goes in this stage. And at this stage, I'm going to go and start simplifying these guys. So this x, this is the same thing as you have 9 over 1. So you'll multiply 9 times 4. Remember, when you have an exponent to an exponent, you multiply. 9 times 4 is 36. 36 divided by 3 is 12. And then we'll deal with the y's. Same thing as 3 over 1. This is negative 3 times 4 is negative 12. 1 times 3 is 3. So negative 12 divided by 3 is y to the negative 4. Okay, so we're moseying on down. Now, I'm going to do this part here now, all kind of in one step, if you will. The cube root of negative 27. Remember what cube root means. Cube root is saying, what number do you multiply by itself 3 times in order to get negative 27? And so that's going to be negative 3. And now what I need to do is I need to take negative 3 and raise it to the power 4. So I have negative 3 all raised to the power 4. Well, we know that negative 3 to the power of 2 is 9. And so what I could do is, if you wanted, you could think of it like so. Negative 3 squared times negative 3 squared is 9 times 9, which will give you 81. So we know that that is equal to 81. Then we have the x to the 12th all over y to the 4. Now you might ask, why did that go down? Why did this go down into the numerator? The reason this slides down to the numerator, right, is because it has that negative exponent. Remember, in order to get rid of a negative exponent, we take the reciprocal of it. In this case, the reciprocal ends up putting it down in the denominator. And as a result, I think we have D. Okay, number 7. Determine a simplified expression for the lateral surface area of the prism below. Right away, a large percentage of students are going to miss this part right here. And they're going to just go and calculate the entire surface area. And my guess is here, I'm not positive, but they're going to have an answer here for the total surface area. Remember, lateral surface area means they only want these sides. That's why they've made these sides gray. And if they could show you that side and the back and over there would be gray too. So that's what we're dealing with. We need to find the surface area of just those sides. So to break this down, what I'll do is I'll just write that we are really looking for the surface area, which, since it's the lateral, we're looking for the front and the back and the left and the right sides. Okay, just so you understand. So 4 different sides. Of course, we know that the opposite ones are going to be equal. So let's deal with the front side, if you will. So this front side right here is what I'm talking about. How many of those sides do we have? We have a front and the back, so I'm going to multiply, or I'm going to have 2. That represents we have 2 of those sides. Now, what are the dimensions? Well, the length, the distance going across here, looks like it's 2x plus 1. And the height of that side would be x plus 2. Okay. Now let's deal with the left and right sides. How many of them do we have? We have two, of course. We have the left side and the right side. We have the distance across, so this distance right here is 2x minus 1, and the height, again, is x plus 2. And now from here, it's just a matter of using the distributive property. And so the way I like to do it is I'm going to leave the 2 kicking it out here. I'm going to go and distribute these. So sometimes your teacher may refer to this as FOIL. That's what I do with my students. 2x times x is 2x squared. 2x times 2 is 4x. 1 times x is x, and 1 times 2 is 2, like so. Do the same thing over here. 2x times x is 2x squared. 2x times 2 is 4x. Then we have a negative x running at real estate, and then minus 2, like so. Multiplying everything by 2 in this bracket, that would give me 4x squared plus 8x plus 2x plus 4. And this one's going to give me 4x squared plus 8x minus 2x minus 4. And now it's just a matter of gathering my like terms. So if I take a look, how many x squareds do I have? I have a 4x squared and another 4x squared that gives me 8x squared. How many x's do I have? I have an 8x and 2x, that's 10. I would add another 8, so that's 18, and then subtract 2, so I have 16x. And then lastly, I have plus 4 right here, and then I have minus 4, so that just gives me 0. So that would be my final solution, and in this case, that looks like that is A. Okay, number 8. Determine an expression for the area of the largest square in the diagram below. So the largest square, of course, is this one right here. They want you to somehow figure out the area of it. Well, it seems to me if we can find out what the side length is of it, then we can just take that side length and square it. So what I see here is you might have seen this kind of diagram before. This is a type of proof, one of many, for the Pythagorean Theorem. And all it's saying is that if you take the area of this first square and you add it to the area of this square right here, it's equal to the area of the third square. And so what we know is we know that this length right here is x plus 1, and we know this length right here is 2x minus 5. So we can use the Pythagorean Theorem to find out what this side is. And I'll call this side, I don't know, let's call it C. Okay, so I'll write the theorem up here. We have a squared plus b squared is equal to c squared. We should all be familiar with that. That is circa grade 8 knowledge. So I'm going to make, let's make a be x plus 1. So I have x plus 1 all squared plus 2x minus 5 all squared is equal to c squared. And at this stage, I see a lot of students make some mistakes. What they like to do is they'll go x squared is just x squared, and then they'll go 1 squared is just 1, and they'll just leave it like this. In actuality, what you have to do is you need to use the distributive property or FOIL, and you'll see that if you thought that was correct, you've missed out a couple terms. So I'm going to write it the long way. Some of you may not have to. You might be math superstars who can do this without, but I'd like to show people what's going on here. Okay, so I'll write it like this to start. That may help. So now I'm going to use the distributive property. X times x is x squared. X times 1 is x. Then you're getting another x. So that would be the part that people would have neglected, and then the plus 1. Okay. Now I'll go and do the same over here. I have 2x times 2x is 4x squared. The 2x times the negative 5 is a negative 10x. Another negative 10x. And then the 25 is equal to c squared. At this stage, I will gather all of my like terms. And when I gather my like terms, I have, let's take a look here, I have 5x squared minus 18x plus 26. And that is equal to c squared. Okay? Now, at this stage, because they want, remember, if I want to find what exactly c was, what I would have to do is I'd have to take the square root of all this. But because then after I found c, I would just have to multiply it by itself again, this right here is actually the expression for the area of the largest square. So if you take a look, there should be one of these here, which looks to me to be D. Okay. Number 9. Derek expanded and simplified x minus 3, all multiplied by 2x squared plus 5x minus 8 as shown below. Looks like my diagram here didn't really work out. Something wrong with the little computer screen I'm using. Okay, hopefully that looks a little better, something like so. Okay, and so let's take a look at what he did. So this is one way of showing your work. You may or may not do this on your own, but we want to see if this makes sense. So if we take a look right here, it looks like this is the expression that we started with. So this is the x minus 3, so that's this part. and then this part going down here is what we have like so. So he went x times 2x squared is 2x cubed. That seems to be reasonable. Then he went the x times the 5x is 5x squared. That seems reasonable. X times negative 8 is negative x. Everything looks good. Now let's deal with the negative 3. Negative 3 times 2x squared gives you negative 6x squared. That looks good. Then we have negative 3 times the 5x. That gives you negative 15x. That looks reasonable. And then we have negative 3 times negative 8 is negative 24. Hopefully you notice that something's a little funky town right there. If we take negative 8 and we multiply it by negative 3, we have a problem. That should have been equal to 24. So in which step did he make his, his first mistake? Well, step 1 looks good. Step 2 looks good. Step 3 was where it would happen. So we would pick C for that one. Okay. Number 10. When 5x squared minus 20 is factored, how many factors are in the result? So, of course, this is a factoring question. They just want you to not actually say what it looks like factored, but just how many factors there are. So whenever you're factoring something, my suggestion is always to see as if there is anything that you can factor out right away. And so what I notice is that I can pull out a 5 out of all the terms. And when you pull a 5 out of all the terms, you'll be left with x squared minus 4. And I'm hoping that something in your brain is going to be saying, ding, 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 we have a winner, because that is an example right here of a difference of squares. And so recall how a difference of squares can be factored. It's the same when you have a squared minus b squared. It's equal to a plus b and a minus b, like so. So remember, you have to be able to take the square root of the first term, square root of the second term, and there has to be a subtraction sign. So in this case, we take the square root of the x, so that'll go there and there. The square root of the 4 is 2 and 2. You make one positive, you make one negative. So how many factors do we have right here? It looks to me like we have 1, 2, 3. Like so. All right, number 11. One of the factors of 3x squared minus 16x plus k is x minus 7. Determine the value of k. So my suggestion here is there's actually many different ways to go about solving this, but not as many in grade 10 that you guys have been exposed to. My suggestion here would be to probably do a little bit of guess and check to see which one of these is even factorable. Because my guess is there's not going to be that many that is factorable. So what I'm going to advocate that you do here is we're going to substitute in the 35 to start. So I'm going to make this 3x squared minus 16x minus 35, and we're going to see if it's even factorable to start out with. So if we take a look, we have 3. So if we try to do this, of course, this is what I call, at least in my class, the AC method. Some people might call it the magic number, or just factoring when the leading coefficient is not a 1. A times C here would be 3 times negative 35, which gives you negative 105. So now what we're looking for is we're looking for what numbers multiply to give me negative 105 that have a sum of negative 16. And so for some of us this may take a while to do. If you take a look right here, I believe it is negative 21 times 5. That multiplies to give you negative 105. And if you add those together, that gives you negative 16x. So I'm going to go now and factor this. And because it is factorable, then now I need to see, is one of my factors going to pop out to be x minus 7? So let's give this a try. So my next step is I break up the middle term. I write this as 3x squared minus 21x plus 5x minus 35. What can you factor from the first two terms? You can factor out a 3x, leaving you with x minus 7, ding, ding, ding. And if we factor out a 5 over here, we have x minus 7. So lo and behold, we found out that one of the factors was 3x plus 5, and the other factor, of course, was x minus 7. So it turns out, determine the value of k that would make that happen. That would have been a. Okay, so number 12 says, when factoring x squared minus 7x plus 6 to the form x plus a, x plus b, which two of the following characteristics are true? All right, so two of these things are true in this list of these 5 things. My suggestion here is, well, first of all, this is a tough question. I find students are going to balk at this a little bit. They may have not seen something like this before. But what you do know is you do know how to factor this thing. So let's just go and factor this to start with. And I think that may help. Okay. So what we look for here is, because the leading coefficient is just a 1, I can put the x here and the x here. We are looking for what numbers multiply to give me 6, positive 6, that have a sum of negative 7. And those, of course, are negative 6 and negative 1. Okay, so remember that I'm basically saying now, because I have this first term as -6, I'm saying A is equal to -6, and I'm saying that B is equal to -1. All right, so that's an important thing to understand right there. So let's start answering these things from top to bottom, see if they're reasonable. First one says A times B is equal to -7. They're saying that when you multiply -6 times -1, that gives you -7. Don't think so. If we take A times B, so -6 times -1, we get 6. That seems reasonable. If we take them and add them together, we get -1. That also seems reasonable. So I would say that 1 is correct. Okay, let's go and deal with the third one here. A is greater than 0. No. Clearly, -6 is not greater than 0. No good. The next one. A and B are both less than 0. That's basically saying they're both negative. That looks reasonable to me. So I would say that that was our answer. Let's just make sure we can disprove the next one. This one says A is greater than 0, B is less than 0, or A is less than 0 and B is greater than 0. That's not the case. We don't have that duality here. So looks like that we have, oops, I don't know why I crossed that one out. We have the number 2 and number 4, which was correct. So I think that is C. All right, number 13, a couple more questions left. Which of the following areas formed by math tiles is factorable? Well, what I would do for this one is I would just move from the top to the bottom and take a look. So what I would do here is make sure that you understand that the shaded ones are going to be negative and the positive ones are going to be the white ones, I guess you could say. So if we look across the top here, I have 2x, so this would be 2x, and then this would be -3 right here. And then across the other side we'd have x, and then this would be, this is kind of strange, I don't know that this would very often happen. We'd have a -2x, or sorry, -2 and then +1, so that would be like -1, I'm guessing. A little bit strange that we would end up seeing something like that happen. So what they're saying then is if you multiply these together, would this ever happen? Well, the problem that I see right here is that you're taking this -3 right here, and or these negative tiles, and you're multiplying it by positive and negative tiles, yet they're all coming out white right here. That is fishy. Okay, so let's go on to B and see if we have any problems over here. This one would be -2x +3, and then on the other side here we'd have -x +3. And so if we were to multiply these together, we would have -2x times -x would give you a positive x squared. So that doesn't really make sense. This should have been white right there, so that's going to be a problem. So that one doesn't look like it's any good as well. Let's go on to C. C we would have 2x -3, and then on this side we'd have x -3 like this. So if we slowly start multiplying this, 2x times x would give you 2x squared. That looks reasonable. We'd have 2x times -3 would give you -6x. That looks good. We'd have the -3 times the x would give you this. So we basically checked all of those areas. We just have to check this area right here. -3 times -3 give you +9. So this part right here should have actually been +9, and it's not, so that's a problem. So I'm pretty sure that the answer is going to be D. Let's just confirm. So across the top here, we have 2x -3, and then on the other side right here, we have x +3 as well. So let's distribute this out. X times 2x would give you 2x squared. That looks reasonable for those ones. 2x times 3 would give you 6x. These are 3x's and another 3x. That's 6x. We have -3 times x would give you -3x. That looks good right there. And then lastly, -3 times +3 gives you -9. So all those regions are good. That would mean it is D. Okay, number 14. Determine the missing tiles labeled W in the tile model below. All right, this is a little bit strange of a question, I have to admit, at least in my opinion. When I first saw this, I know I had trouble just trying to figure out what they were even asking. But if you remember, when we're dealing with algebra tiles, we normally have tiles on this side. So you'll notice that they have this on this side here, which kind of tells you what they have over there. Well, they just want to figure out what the length of x is. And so we see that x is that length right there. this length is x, and these, because they're gray, would be a -1 and a -1. So the distance of w there is 2x minus 2. And so if they asked you to express in terms of algebra, that's how you might have written it. In terms of algebra tiles, you would just say 2x is a minus 2. It ended up being b like so. So kind of it ends up being an easy question, but a little bit strange when first looking at it. All right, so they throw at the very end here a couple of these numeric response questions. So remember, for these numeric response questions, they're not necessarily any more difficult than what you would have before. But what you're going to have is you're going to have these little boxes where you're going to enter your answers. And so you don't get any credit for necessarily showing your work, which you don't get any credit for it. But they give you some space here to write your answer. So this is kind of what it's going to look like. You're going to get one of these things to enter your answer in. So what we'll do is we'll solve this, and then I'll show you how you would enter this in, and where you would not get credit for this. So you got to be quite specific with your final answer. So if we take a look at this, maybe I'll just rewrite it, this part down here. We have the x is raised to the power of 10, and then we take the nth root of it, and it's equal to x squared. So I want to know what is n right here. So remember that if we want to, we can write these radicals as powers. So remember, the 10 goes on top and the n goes in the bottom. So what they're trying to do is they're trying to figure out what number would you have to put in for n such that this would be equal to x squared. Now, of course, without a whole lot of difficulty, we should be able to see that if you substitute in 5, you have n is equal to 5. 10 divided by 5 is 2. So we know that our answer is 5 right here. Now the answer is exactly 5. All right. So I'll tell you how this kind of works. You're going to get credit if you wrote in 5 like this. Okay. If you don't bubble in the positive, they just the test maker basically assumes that you've answered a positive. Okay. If you put the positive, of course, that would be fine too. The problems you're going to have is if some students want to put in zeros right here. Okay, so what this is telling people in mathematics land is it's telling you that you've rounded to 1 decimal place. And so because the answer is exactly 5, you want to leave these zeros out of it, all right? So the way that you're going to get full credit for it is just simply putting in that like so. Okay, so that'd be your solution for that one. So that's a good example of a written numeric question because often they're not that difficult. They're very doable, if you will. It's just a matter of you kind of taking your time and being very careful, especially when you code in your answer there. So the last one here we have on this short little exam review is 16. When we have 7, and we have the 4th root of 7, all raised to the power of 9, and then we have the 5th root of 7, all raised to the power of 3. So when those are multiplied, they want you to simplify it so that 7 raised to the power of some n. All right. So what we're going to try to do is we're going to try to figure out, of course, what that n is. So my suggestion to start with would be to go and write these as exponents first. So this first one, of course, is 7 to the power of 9 quarters, and this one would be times 7 to the power of 3/5. Now remember, when you are multiplying the bases right here, what do you do with the exponents? We add them together. So this is the same thing as writing 7 9 quarters plus 3/5. And this now is taking you way back to perhaps grade 8, maybe grade 7. Whenever you're adding fractions, you need to get a common denominator. In this case, a number that both 4 and 5 go into is 20. So I'm going to write this all out of 20. So what you need to multiply this 4 by in order to get 20? You'd have to multiply by 5. So you have 45. What do you multiply this 5 by in order to get 20? You have to multiply it by 4. So you have 12, like so. And now we add this up, and you have 7. All raised to the power of 57 all over 20. Okay, and so the interesting thing is when you code in these little answers in those little boxes, you're not going to be able to code in fractions. And so what they want you to do, remember right here, got to make sure you read the question. It said answer to 2 decimal places. So in your calculator, what you're going to do is you're going to take 57 over 20, because of course at this stage you'll be able to use your calculator. And if you do that, you're going to get 2.85. And so all you need to do then is write in 2.85 like this. And of course, if you wanted to, with these little, these little plus minus things here, you could code in the positive. Okay. So that concludes the algebra and number provincial exam review. I'll be producing more of these to come. Thanks.